Hello all and welcome to the joint presentation of EGI notebooks and C-Scale notebooks, or in other words, the C-Scale Interactive Analytic Environment. The C-Scale project brings together providers of Earth observation data from around Europe. None of the providers in the Federation has all of the data for the Copernicus program, for instance, or even for Sentinels. But each of the providers holds a separate archive of data that are of concern to them. For instance, for a national territory or for a specific area of interest, like a specific type of observation or a specific period in time. But the idea behind C-Scale is bringing them together. So federating these providers with also providers of processing resources, and making sure that the user can traverse the federation as seamlessly as possible and access resources from different providers with ease. To achieve this seamless experience, we need to address two separate areas. The first of them is discovery, where the user needs a tool that will allow them to discover data they need across the multiple providers in the federation. And the second area is access, where the user needs to be able to either access the data completely openly or to use a federated identity so that they do not need to pay attention to what provider they are actually getting the data from. They can use a shared identity to get the data from all the providers. Before we begin the actual demonstration, I will briefly introduce the scenario that you are going to see implemented in the notebooks. Here we have a user and a bunch of providers with storage of data. The user has a notebook, and the first step that they want to perform is discovery of data that is relevant to their need for analysis. They might, of course, go side by side because all of the sites provide their own catalogs, but with a growing number of sites in the Federation, this might be quite tricky. So the C-Scale project is providing a centralized component, the Earth Observation Metadata Query Service, that can be contacted instead. So the user asks the Metadata Query Service, and the Metadata Query Service redistributes the query to all of the sites that are members of the Federation, or at least to all of the sites that are likely to hold the response for the user. The sites that actually have data matching the user's query send a response back to the Metadata Query Service, which in turn collates the results and sends them to the user. So the user now knows where to go for data. The second step they need to perform is actually accessing the data. For that, they need to begin with authenticating to the site. And in the Federation, there is a centralized component, the EGI check-in, which has actually provided already the user with a token that can allow them to do just that, access all sites with resources in the Federation. The token has already been preloaded into the notebook when the user first logged into the notebook. So now we already have an access token. We can use it to identify ourselves to the site of our need and download the data for our analysis. And the last step that remains to be done is the actual analysis of the data that in this case takes place already locally in the notebook. So the whole infrastructure has already done its job. So I hope I was able to give you a good picture of what we are trying to show with the notebook. And with that, I will hand over to my colleague Petr, who is actually going to show you the notebooks in action.
Hello, my name is Petr, and I will guide you through this part of the demo where we have prepared 3 Jupyter Notebooks, as you can see here above. We would like to demonstrate how to search for the data through the C-Scale Metadata Query Service or MQS, how to download and process these data and run some simple analysis in the end. We are going to access a stack catalog using the PyStack client library, which implements basic stack concept. While using Jupyter Notebooks environment, we have to install some necessary Python libraries and some useful functions as well. For the search through the stack catalog, we will use getCollections method that can fetch collections from collections endpoint. We can print the result and check for ourselves. We can make use of links attribute to check for the actual number of collections, for example. It is possible to access metadata of a single collection, like here. Here we are looking at collection with Sentinel-2 satellite images. We can click here and make a survey through details. We can find details about spectral bands that we are going to use later in this demo. Here you can find web links that you can copy-paste and put into your browser. We can access metadata programmatically as well. One of the most useful features is to get the time window of a particular collection. Stack API offers an opportunity to search catalogs using variety of search criteria, typically time, place, or type of a satellite images. Here we are looking for Sentinel-2 satellite images covering EU region. We can create GeoJSON file using this online platform to define the region of interest for our search criteria. After defining our search criteria, we can create a collection out of collections containing only Sentinel-2 satellite images. As before, we can check for time window of each collection. Our region of interest, which is Europe in our case now, we define as a bbox coordinate. Then we can search through our collection using parameters we have defined. Consequently, we can plot a result to see how the EU region is covered. We can make a color-coded graph to see which collection covers which European region. Now we will narrow down search for a specific area within EU region. This first example makes use of the intersect parameter, for which we will use GeoJSON file again. This file contains coordinates of city of Utrecht and its surroundings. We are going to search through one of the Vito collections, and we are successful. We can pick a date of observation, for example this one, and we can visualize this item in a stack browser. We can verify here that the satellite image really contains city of Utrecht and our desired date. Next, we can download a preview of original satellite image. This is useful mainly for the cloud cover check. We are lucky that there were almost no clouds, so we can see the ground. Second example of item search make use of the bbox parameters as we saw before, but this time we will look for the city of Prague. We will search again through our Sentinel-2 collection, and as you can see, only 3 of 5 collections contains the Prague region. And now we can use one of the most useful parameters within the collection, and that is cloud coverage. We can either print or more conveniently plot the cloud coverage over the region. We can use this interactive graph to inspect the cloud coverage over the area during the time. Satellite images with no clouds are crucial for our purpose of image analysis. So let's find some. Let's look into just one collection and search for near zero cloud coverage. Good. We have some days without clouds. Now we can choose the day, but let's keep this one. We can quickly check on the map here. Maybe we don't like this trapezoid shape of the tile, so let's try another one. That's better. And again, we can verify in browser that we really have what we wanted. Perfect! We have chosen the data and now we want to download them. Since the provider of the data requires authentication to access their data, we need to include authentication details on our download request, which is easy to do as the required access token is already present in our notebook. We can check attributes of the token and what it says about us, and mainly whether we can access C-scale data providers. And it seems we can. So let's download some images. First, we will download TCI image, which is RGB image of the ground segment we chose. Next, we download all the spectral bands we will use for the analysis. It takes some time, so let's check whether it is really doing something. Good, it's working! At the end of the first notebook, we can show the RGB image in full resolution, but this in reality takes almost 4 minutes. But here we can use the miracle of movie editing so we can see the image almost immediately. And now let's move to the next notebook. This notebook shows how to locate position of the downloaded images using OpenStreetMaps and how to pre-process data before analysis. We need again some Python libraries as well as input a location of our images we downloaded using previous notebook. We have to load TCI image again, but this time we will skip showing it. Instead, we will show the region of the satellite tile in OpenStreetMap. It is basically the same as in the browser, but here it is more interactive. We can add our region of interest from our GeoJSON file. We can mark this region over the full resolution data. Now we prepare the clipped images of our downloaded region. Here we can see the clip image in detail. And in the end, we can show clipped image in the OpenStreetMap. These steps we have just shown are not specific to C-scale, therefore we went through this notebook quite quickly. That's the same case for our next and last notebook, where we want to offer you some possibilities what to do with the data further. It is good to know that not all of the Sentinel-2 spectral bands possess the same resolution. Therefore, we need to resample them. That is what we do at the beginning of this notebook. Then we can create different spectral indices. These indices represent different parts of the Earth's surface, like vegetation or water. We can create water mask, which highlights only water surfaces. Then we can overlay this mask over the true color image. We can play more with spectral bands. Mixing them together results in different color-coded images, which represents different areas on the ground region. Hence, we can highlight more buildings, forests, fields, or lakes and rivers. And now we can even more narrow down our analysis and pick only a city area. In our case, it is a city of Prague. Again, we can visualize overlay images where we can show the borders of Prague or any other region. We can do basically the same as before and look for green and water areas. The only thing we need to keep in mind that every time we use new satellite image for the analysis, we need to adjust the mask parameters as well. What you can see here, these are two masks that represent different areas in Prague just by changing the parameter of the same mask. we can now highlight the green parts of Prague. By adjusting our water mask, we obtain a nice profile of a river Vltava. Finally, we can obtain something like this image, which is a composition of true color image with green and water mask overlaid. In the end, we can save our image for presentation or any other purposes.
Thank you, Petr, and now for the conclusion. So what we have seen was a simple demonstration of a user using the C-scale interactive analysis environment to perform simple tasks. Firstly, to discover data across the federation, and then access and download the data for local analysis. It is important to stress that all the tools and services demonstrated in this scenario are also available for automated use, so that once you have developed your workflow to a production level, you can just have it multiplied by robots as many times as you want, and the federation will support it. And that's the main message. It's time to close. This demonstration was prepared for the EGI 2023 conference in Poznań. If you are coming there, we are looking forward to seeing you in Poznań. And otherwise, goodbye and thank you for watching. Thank you, Petr. 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 And now for the conclusion.